An enormous and endless universe has always held secrets that we couldn't have imagined. Imaginations often fall short, and frequently. These mysteries restrict the dissemination of information important to the development of science. Most recently, advanced telescopes have discovered an anomaly that defies all logic, a cosmic mystery that has left scientists around the world perplexed. The James Webb Space Telescope has challenged the Big Bang Theory. Joel Rohn investigates the matter more deeply. Check out this telescope's most recent discovery: the shocking disappearance of 900 trillion stars. The $10 billion James Webb Space Telescope has been operational in space for more than 2 years, and the outcomes already demonstrate that the investment was worthwhile. The telescope is significantly better than Hubble, providing unprecedented views of deep space. In July 2022, James Webb spent a very long time exploring wavelengths coming from distant galaxies. Detecting radiation outside the visible spectrum in the redshifted ultraviolet range, the telescope has revealed incredible details beyond our previous expectations, showing areas of space that Hubble could not observe. Most disturbingly, however, James Webb has identified the mysterious disappearance of 900 trillion stars in the empty regions of space. This finding raises disturbing questions about how these stars could have disappeared without a trace. Every new piece of information lends an air of mystery and concern. Observations performed by the James Webb Telescope detected the disappearance of trillions of stars without a trace. The question is, why? There are two primary theories regarding their absence. The first theory suggests that the stars remain, although their deaths may have been accompanied by a decrease in luminosity, possibly concealed by dust, or having simply collapsed into black holes without going through a supernova stage. The second theory is more alarming. It could be that the universe is undergoing a process of disappearance that we cannot stop. It has been almost a century since scientists proposed that the universe was expanding, and that the farthest galaxies appear to be moving away from us at an ever-increasing speed. This expansion doesn't mean that galaxies are physically traversing space, but that the fabric of space itself is expanding, causing galaxies to move away more quickly. This model, dominant since the 1920s, was updated 20 years ago when it was discovered that the expansion is accelerating. As time goes on, galaxies are receding from us at increasing velocities, becoming impossible to reach even if we could travel at the speed of light. When we look at a star whose light has traveled 100 years to reach us, we are observing a star 100 light-years away. However, when we look at a galaxy whose light has traveled for 100 million years, that galaxy is not just 100 million light-years away, is even farther. This is because, on galactic scales, the expansion of the universe plays a major role. The longer it takes for light to reach us, the farther the source actually is. Due to the ongoing expansion of space, this phenomenon manifests itself as redshift. As light moves through more space, its wavelength stretches. If there were no expansion, the wavelength of the light reaching us would remain constant. But because of expansion, the wavelength stretches, causing light to be redshifted. The significant redshifts we've observed, especially in the farthest galaxies, confirm that the universe is expanding. But our job is not just to verify this expansion. We can use the data collected to understand how the universe has changed over time and what it's made of. When sunlight or light from a distant cosmic source travels through the expanding universe, its wavelength is stretched, producing redshift. This effect is more pronounced for objects farther away, since their light has been traveling longer. By determining the redshifts of many sources and comparing their apparent brightness to their actual size, we can retrace the entire history of the universe's expansion. Additionally, the way the universe expands is influenced by the different types of energy and matter it contains, allowing us to learn more about its composition. Approximately 68% of the universe is made of dark energy, modeled as a cosmological constant. Around 27% is dark matter, and about 4.9% consists of protons, neutrons, and electrons. Only 0.1% is composed of nutrients and antinutrients, and 0.08% is photons. Other exotic entities such as cosmic textures or strings have not been found. Knowing the components of the universe with such precision allows us to apply Einstein's general theory of relativity to forecast its future. As a result, we discover that the universe is dominated by dark energy. This finding implies that galaxies not gravitationally bound to us will eventually move away at ever-increasing speeds. As this unchecked expansion continues, the distance between these galaxies and us will rise, giving the impression that they're moving away faster and faster. This leads to an even more alarming conclusion. At great distances, the fabric of space itself expands so rapidly that a photon leaving our galaxy for a distant one may never reach its destination. The expansion rate of the universe is now so fast that we are losing the ability to reach even relatively nearby galaxies. Even if we could travel at light speed, many of these galaxies only 18 billion light-years away are becoming unreachable. The overall expansion is still accelerating. The density of matter and radiation continues to decrease. Our observable universe is about 46 billion light-years across. Assuming galaxies are evenly distributed, only about 6% of all galaxies in the current universe are accessible to us. This means that even if we traveled at the speed of light today, we'd only be able to explore a tiny portion of the universe. Additionally, an estimated 20,000 to 60,000 stars become unreachable every second. Although the light they emitted a second ago will still reach us, the stars themselves never will.
Ow.
This fact is unsettling, but it also reminds us how precious each moment is. From a more optimistic perspective, reality serves as a reminder that if we ever hope to travel beyond our local group of galaxies, including Andromeda, the Milky Way, and about 60 satellite galaxies, then every second that passes is a lost opportunity. Of the estimated 2 trillion galaxies in the universe today, only 6% remain accessible from the Milky Way. This percentage is still falling, meaning that 94% of the galaxies we can see are already beyond reach due to the accelerated expansion caused by dark energy. As time goes on, every galaxy outside our local group is destined to move even farther away. Unless we develop the ability to travel to other galaxy groups and clusters, humanity will remain trapped in the local group, and our ability to send or receive signals from other parts of the universe will vanish. The accelerated expansion of the universe is relentless, and the gravity we possess is not enough to counteract it. The universe is constantly expanding, and, unfortunately, there's nothing we can do about it. If you liked this video, please subscribe and give it a like. This helps us continue creating the best content.